Hello and welcome to the Edu Club. Today we are going to learn what is derivative. Now, talking about derivative, first of all, meaning of the word derivative. Now, your derivative means simply if we are given an object and we are aware of all the dimensions and areas of this object, and we are told to find the area and approximation and all the other stuff of a small part of this complete object, it is called as derivative. To be very simple, entire information about a big object is given going from bigger to smaller. Going from bigger to smaller is called as derivative, and opposite of derivative is integration. Integration means you are aware of a small part and you are asked the entire information about the complete part, that means from smaller to larger thing. It is called as derivative, it is called as integration, and from larger to smaller. Larger to smaller is derivative and smaller to larger is integration. Now the symbol of derivative is d upon dx. D upon dx. Now what is the meaning of this? How to read this d upon dx? D upon dx means derivative with respect to x. Derivative with respect to x. Derivative with respect to x. Now what is this x? Suppose for example, we are asked derivative of a function which is like x square. Now the function is written in the form of x, right? So we need to find the derivative of this function, and it is given with respect to x. Suppose it would have been in this form, d upon dx of y square. Now derivative with respect to x of a function which is in the form of y, not x. So with respect to x, y is a constant, x and y do not have any relation. This means that y has become a constant. Okay. Here now it can be, or it is not at all necessary that the derivative will always be in the form of x. It can be d upon dy, it can be d upon dp, it can be d upon dz, anything. Usually there are two forms only, d upon dx, derivative with respect to x, derivative with respect to y. These are the two most common derivatives. I have shown you the symbol also. What is the symbol of derivative? Now moving ahead with the first function. Suppose d upon dx, this means symbol of derivative, derivative with respect to x, derivative of x raised to n. Now what is this n? N is any number, any integer, x raised to 1, x raised to minus 1, anything. So how we will find out the derivative of x raised to n? It will be n in front, n will come in front and x raised to n minus 1. Don't worry at all, let's see it with the help of an example. It is asked find the derivative of x raised to 2. At the place of n, what is there? 2. So what does the derivative formula says? It says that n should come in front and x raised to power n minus 1. Here n is 2, so 2 should come in front. X raised to 2 minus 1, which is equals to 2x. Guys, a very interesting, very simple topic. Only and only if you are aware of the basics of derivative. So now this was the basic first formula. Give it number 1. This was the basic first formula. We have given it a number 1, and we have seen how to find out the derivative with the help of this formula. For example, we are given derivative of x raised to 10. What it will be equal to? The formula, it is in the form, see this, it is in the form of x raised to n. Right here also x raised to, instead of n we have got what? 10. So what the formula says, that n will come in front and x raised to power n minus 1. So here 10 will come in front, right? X raised to 10 minus 1, which implies which implies 10 x raised to 9. This is the answer of the derivative of x raised to 10. Now the second derivative with respect to x of log of x, it is equals to 1 upon x. Simply, no tension. Derivative of log x is 1 upon x. Let us elaborate it with the help of an example. Suppose it is given 2 log of x. So what it will be equal to? 2 is the constant. So what will we do? 2 will take 2 outside the derivative symbol, log of x. So 2 into derivative of log of x, we are aware. What is the derivative of log of x? 1 upon x. So it will be equal to 2 into 1 upon x, which is equal to 2 by x. This is simply the derivative of log of x. This was the second formula. Okay. Now the third formula. d upon dx of e raised to power x is always equal to e raised to power x. Just keep this in mind. Derivative of e raised to power x is always e raised to power x. Now coming on the fourth formula. Derivative of a raised to power x is equals to a raised to power x log of a. Now what is a? A is any constant. It is always in the form, for example, we will take an example, derivative of with respect to x of 2 raised to x. So see, it is in this form. Instead of a, it is 2 here, 2 raised to x, a raised to x. I told you here a can be any constant. So what will be the answer of this? A raised to power x into log a. So it will be equal to 2 raised to power x log of 2. Now moving on with the fifth formula. It is equals to derivative of root x. Now derivative of root x is 1 upon 2 times of root x. Why this is so? Chalo, let's see the explanation for this. Can we write root x as x raised to power 1 by 2? Right. Now in the starting only the first formula which we saw was x derivative of x raised to power n is n x raised to n minus 1. And in this case, instead of n, here it is 1 by 2. So what it will be? 1 by 2 will come in front, x raised to 1 by 2 minus 1, which is equals to 1 by 2 x raised to minus 1 minus 2 upon 2, which is equal to 1 by 2 x raised to minus 1 by 2, which is again equal to x raised to 1 by 2 into 1 upon x raised to positive 1 by 2. Here it was minus 1 x raised to minus 1 by 2 in the numerator. When it will go in the denominator, it will become x raised to positive 1 by 2. But x raised to positive 1 by 2 is equal to root of x. So therefore, multiplication of these two gives 2 root x, which is equal to this. Hence proof. Right? Now moving on with the sixth and the last formula of this category, which is equals to derivative of constant is always equals to 0. Now what is meant by a constant? Constant can be anything like any alphabet, any number. For example, derivative of 2 is 0 because 2 is a constant. Derivative of a is equals to constant because a is also 0. So up till now we have seen 6 formulas. Now we need to remember these 6 formulas. The first was very important. It was derivative with respect to x of x raised to n. It will be equal to n x raised to n minus 1. The second one was derivative of log x, which was 1 by x. Third was derivative of e raised to power x, which is e raised to power x. Fourth was derivative of a raised to power x, which is a raised to x log a. Fifth one was d upon dx, that means derivative with respect to x of what it was, a raised to x, e raised to x log x, x raised to power n. Remaining is root x is 1 upon 2 root x. Sixth is d upon dx, that is derivative with respect to x of constant, which is 0. So up till now we have seen these many derivatives, these many formulas. These are very, very important. Without knowing these 6 things, we cannot proceed any further. Now let us take an example based on these 6 formulas. So we need to calculate, find derivative of 7 raised to power x plus log x plus root x. What it will be equal to? The question is find. So we'll do one thing. First we'll open the brackets. So derivative of 7 raised to x, d upon dx will get multiplied to each and every term. D upon dx of log of x plus d upon dx of root of x. Right? We have done what we have done is we have just opened the brackets and we have multiplied d upon dx with every single term. So we are aware of 7 raised to power x. It is in the form of derivative of a raised to power x, which is equals to a raised to power x log of a. So what will be the derivative of 7 raised to power x? 7 raised to power x log 7. Okay. Next is plus sign. Derivative of log x. We are aware of derivative of log of x, which is 1 by x. Derivative of root of x, right? Derivative of root of x is 1 upon 2 root of x. Find, second question, find derivative of 19 raised to power x plus log a plus x. Okay, this is the question. So let's open the brackets. D upon dx of 19 raised to power x plus d upon dx into log a. Log a is constant, remember. A here is a constant, we are not aware of the value. D upon dx of x. Now this is of the form a raised to power x. So 19 raised to power x log 19 plus derivative of log of what it was? Log a. Log a is a constant, derivative of constant I told you, which is equals to 0, and finally derivative of x. Here it is like dx dx, you can do memorizing this form as well, or it is equals to d upon dx of x. X is x raised to 1. So 1 will come in front, x raised to 1 minus 1. Right? 1 minus 1 is 0. So x raised to 0 or anything raised to 0 is 1. So 1 into 1 is finally 1. So the answer is 19 raised to x log 19 plus 0 plus 1 in this is 0 plus 1, 1. So answer is this. 19 raised to x log 19 plus 1. Now moving ahead, I will give you an example. You try to solve it. Derivative with respect to x of x log x. Now please keep one thing in mind. It is, suppose a normal man will do it like d upon dx of x into d upon dx of log of x. Let me tell you people, this is wrong. Okay, we are having a separate formula for it. It is of the form u into v, right? These both are in multiplication. So we have a formula for this. Derivative with respect to x of u into v, it is equals to u derivative of v plus v derivative of u. So the derivative of x log x will be equal to u, this is, suppose this is u and this is v. So just keep in the formula. Instead of u, here it is x, d upon dx of v. V is log x plus v, that is log x into derivative with respect to x of x, which is equals to x, derivative of log x is into 1 by x plus log x, derivative of x is 1, or directly you can simply cancel those things. 1x, x into 1 by x is also equal to 1. So finally the answer is 1 plus log of x. Very important formula. This is the seventh formula here, right? Example, derivative of 2 raised to x log x square. Okay, so to solve this, again there are two parts, 2 raised to x into log of x square. So these two terms are in multiplication, so again we can use the same formula, u into v. The form is u into v. So let's start derivative, so formula for u into v, derivative of u into v, you must learn this. U into v is u derivative of v plus v derivative of u. So do the same here, u as it is derivative of v, that is log of x square. And one more important thing, the property of log of x square, 2 comes in front, right? So 2 raised to x derivative of 2 log x plus v, that is log of x square derivative of u, that is 2 raised to x. Simple. 2 raised to x as it is, 2 is constant, to take it out again, and derivative of log of x is 1 by x. Again plus sign as it is, derivative of log x square. So not the derivative, just log of x square, which can be written as 2 comes in front, property of log into a raised to power x. So 2 raised to power x log 2. Now just simplify it. It will be like 2 raised to x into 2 raised to 1. It is equal to 2 raised to x plus 1 whole upon x plus 2 raised to 1 or 2 raised to x. So it is 2 raised to x plus 1 into log x into log 2. This is the final answer. For further more videos, please do like, share and subscribe. Thank you. Have a good day. Bye bye.